Okay, so the plan is for us to do the first part of your final review. Let's go ahead and read the first question. It says, calculate the average speed of a car going 500 meters in 30 seconds. By the way, if you lose the sheet, I already uploaded it to the iLearn. So you can find that there as well. So what are the three things I asked you to do when you read a question? Read it. What is it asking for? And what is it giving? So what did they give you? So they gave you 500 meters. What is the 500 meters? What is that considered? A distance. That's your distance. Okay? What else did they give you? 30 seconds. What is that? Time. What are they asking for? Speed. Do we have a formula that gives us the speed using these two pieces of information? Yes, we do. What is it?
Distance over time.
Distance is 500. Time is 30. What is that equal to? We have calculators up here. You can come up and grab it. I'm not solving everything for you. So 500 divided by 30 is 16.66 or 16.7. What is the unit? Meters per second.
16.7?
Yes, it's 16.666 meters per second. All right, so that's number one. Number two. Number two said, for the graph to the left, the object has a blank velocity and a blank acceleration. The graph looked like so. And we have time down here and position over here. Okay? So what can you tell me about the velocity first? What's the first thing you're going to look at? What is it? You're going to look at the graph. And you're going to focus on what it's given you. Right? What else? I'm sorry? The line. What is the line? How is the line behaving? Okay? So as time passes, what's happening to the position? It's decreasing. Okay? So if I'm looking at my formula for speed, we said speed is equal to distance over time. As time gets greater and greater and greater, okay, the distance is getting smaller and smaller and smaller. So here's what I would like for you to look at in this situation. Plug in any number you want and compare it to any other number. So if my distance was 5, okay, and my time, so let's take the distance 5 over here. My time at that point was what? Probably was around, we're going to say 3. Okay? I'm going to choose any other point on the graph. I'm going to say, okay, so at my distance 3, my time was around 6. So what's happening to these numbers? 5/3 is equal to around 1.6. 3 over 6 is equal to? Is 0.5. So what's happening to the numbers? They're decreasing. So what can you tell me about the velocity? It's a decreasing velocity. And what is happening to the acceleration? So if you start up with a speed of 1.6, or let's pick a point all the way up here, and we see the speed. The speed started up at around 2 seconds. You were at a very, very high position. Okay, very high number. Okay, let's say you were at 30 at time 2. We're going to do at 2 seconds. Okay, 30 over 2 is around, it's 15, right? All of a sudden, your speed went from 15 to this number over here that we figured out, and it was 1.6. Your speed went from 15 to 1.6. What happened to your acceleration? It decreased, and it decreased tremendously. Okay? So your acceleration decreased. Next question, number 3. Said, number 3 is asking if a car speeds up from 0 to 30 meters in seconds, to 30 meters seconds in 2 seconds, calculate the acceleration rate. So, we read the question. What's given? So the speed went from 0 to 30 meters per second. And your time is 2 seconds. Can you calculate the acceleration? What is the formula for acceleration? Acceleration, not for speed. Exactly. Thank you. So we say the change in speed over time. So what is the change in speed? 30 minus 0 divided by, what's the time? What's the time? 30 divided by 2 is? What's the unit? Meters per second squared. And that is your number 3. Okay? How are we doing? Okay. Number 4 says if a car slows down from 35 meters per second to 20 meters per second. Okay, again, we have a speed that slows down from 35 to 20. Okay, meters per second. That's for number 4. In 7 seconds. So your time is 7 seconds. How can you calculate the acceleration? What did we say the formula was? Again, this is my formula over here. The change in speed over time. Okay? So again, my change in speed is my final speed minus my initial speed, which is 35 minus 20 divided by the time. What is the time? 7. So 35 minus 20 is 15 over 7. 15 divided by 7 is 2.14. Is it from me?
Where did you get 35 from?
When you read the question said your car slows down from 35 meters per second to 20 meters per second. Okay? So 15 over 7 is 2.14. What is your unit?
Meters per second.
Meters per second squared. That's the answer for number 4. Any questions? Okay, let's. Okay, question number 5. If a car accelerates from rest at 4 meters second squared for 7 seconds, what would be the speed reached at 7 seconds? So we read the question. What do we have? We have an acceleration. So that's number 5. Your acceleration is equal to
4 meters.
4 meters second squared. What else are you given?
Time.
Time is equal to
7 seconds.
7 seconds. What are we being asked for?
Speed.
Speed is equal to what? So, which formula are we using? Again, the acceleration, right? Okay. So if I say distance over time, what happens? Do I have distance? So how can I use distance in my equation? What do I have? I have acceleration and I have time. Which formula from your list can satisfy this question? Look at your formula sheet. Can we rearrange the acceleration formula? Tell me the acceleration formula one more time. Acceleration is equal to change in speed over time. Do I have acceleration? Do I have time? Can I find the change in speed? Yes, I can. So that's all I have to do. How do I do that? So, change in speed is equal to your acceleration times time. Acceleration is 4 times your time is 7. 4 times 7 is 28. What's the unit? Meters per second. Yes?
Will we be using the formula for the first part of the, like that formula?
Uh-huh.
Just that formula?
So, well, you can use this formula for this question, but earlier on we used the other formula that has to do with speed only because we had a distance. In this situation, we can't use the distance over time because we don't have distance, but we have acceleration. So all we did is rearrange.
It's your 2 triangles, right?
Okay, if you look, I'm going to go over the triangle for those of you who forgot. This is what my triangle looks like. So when we're using our triangle, we always cover up what we don't have and see what we need to do with the other 2 items that we have. In this case, we have what? Acceleration, and we have time. So this is the line of multiplication right here. So acceleration times time gives me the speed. Okay? Earlier, in an earlier question, we had to find the acceleration. So you cover up the acceleration and you use the division line to divide change in speed over time. Okay? We do the same thing when we do speed, distance, and time. And you just fill them in your triangle. I'm just going to finish this up since we talked about it in this slide. So your speed or velocity is always equal to your distance over time. You cover up what you don't have and you use the other 2. So speed is distance over time, time is distance over speed, or distance is speed times time. Yes?
Are we allowed to use like a paper at the final or like a notepad?
Yes. But I am giving you the formula sheet. You are not allowed to get your own formula sheet. I will give it you. Nope.
Not this one?
It's a different one that the district came up with.
So would it be like a full sheet of paper?
It's a full sheet of paper with formulas all over it.
But like the one can we write on one? You get a note card. Like a note card, yeah.
You come up with one that you can bring to your final? No. All right, next question. Number 6 says, an apple falls from a tree in an orchard. Okay? So an apple falls from a tree in an orchard. Assuming gravity is 10 meters per second squared, what was the speed of the apple after 2 seconds? So we read the question. What do we have? We have 10 meters per second square as acceleration. Thank you. So your acceleration is equal to 10 meters per second, which we already know that this is our gravity acceleration that we normally use. The right gravity acceleration number is what? 9.8. Awesome. But this is what we use just to make our life easier. Okay? What else did they give us?
Time.
They gave us time. What's the time? 2 seconds. What do we need to find? We need to find speed. Again, which formula are we using? Okay. Speed is equal to acceleration times time. A times t, which is equal to 10 times 2, which is equal to 20. What's the unit? Meters per second.
See, when do we know what to use meters per second squared?
That's your acceleration unit.
Okay, so when we're looking for acceleration, what's squared after?
Yes. Anytime you see meters per second squared, that's your acceleration unit, whether it's given to you or you need to find it out. Acceleration unit is meters per second squared. Velocity unit or speed unit is
What was it? Meters per second.
meters per second. Time unit is,
Second.
distance unit is, awesome. Okay? We're good? All right, moving on. Number 7. Let's look at number 7. It says, a free-falling object is constantly accelerating at 10 meters per second squared, or we can use the 9.8. Either way, if I ask you a question like that, 9.8 is the actual number that we use in science because that's the accurate number. But for easier purposes, we use 10 in the classroom. So number 7, it is, we can put 9.8 meters per second squared. Okay? As, excuse me, as the car slows down on a highway due to traffic, its velocity does what and its acceleration does what? Car is slowing down. So for number 8. So what's happening to its velocity? Decreasing. So decreasing velocity. And as you're decreasing the velocity, what's happening to the acceleration? It's okay. Here's one thing I want you to start using. Acceleration can be in the positive direction or in the negative direction, right? But either way, acceleration is moving fast. But it's moving fast to slow you down or moving fast to speed you up. Okay? Yes. Yes, sweetie. The first blank, velocity is decreasing. Okay? What's happening to the acceleration? As you slow down, what happens to the acceleration? In which direction? In the negative direction. Okay? So, you can say increase in the negative direction, or you can, if you have an option of increasing or decreasing, your acceleration is actually decreasing.
In the positive direction?
Negative, minus.
Wait, I'm decreasing in the positive direction and increasing in the negative direction, right?
Yes, so it slows you down. So you are going towards a number very fast. But which number?
Negative.
Negative number. Okay? Okay. So number 9 says, air resistance blank the acceleration of a free-falling object. Does it slow down a free-falling object or does it speed it up? It slows it down. Air resistance. Air resistance goes in the opposite direction of a free-falling object, right? It's resisting the movement downward. Remember when we had that example of the person jumping in a parachute from an airplane? What happens when the person jumps at the beginning? They're going down, right? They're going down very, very fast, right? What happens when the parachute opens? It pulls them back up, exactly. Pulls them back up because of what? Because air resistance is filling up the parachute and it's pushing them back up. So it slows them down, right? Because if you stay going down, 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 down without opening the parachute, what happens to you? You're going to land on the floor and probably not alive. Okay? But if you open the parachute, what does it do to you? It slows you down. Okay, again, air resistance does what to the acceleration of a free falling object? I'm sorry? Okay. Decreases the acceleration of a free falling object. Okay, so that was number 9. Decreases. Okay, number 10. Number 10 is asking us, if an astronaut weighs 100 newtons on Earth, his weight will blank on the moon. Okay, let's take a look at this from a different perspective. What did we say about gravity on the moon? We said it is 1/5 of the gravity on Earth, right? Okay. Let's go on and talk about weight. Your weight is equal to, exactly, mass times your gravity. So your weight is in newtons and it is 100 newtons. We don't know what your mass is, but we know that gravity is 10. Okay? So 100 divided by 10 will give me your mass, right? Which is 10 kilograms. Okay? So that's for a question that's asking me about a mass, or a question that's asking me about the weight. But now I have a given of a weight, which is 100 newtons, and it's asking me, okay, so if on Earth you were this much, what happens on the moon? You are 1/5 of that much. So is your number increasing or decreasing? It's decreasing, and that's what you choose. So 1/5 of 100 newtons is smaller. So it will be decreasing. Okay? For number 11, the question is asking, if an object is accelerating 5 meters per second squared every second that passes, that object gains how much velocity? Let's see what we have. The question is asking us, so we can always use what we know or use the formulas we know to find information. The question is giving me the acceleration to be 5 meters per second squared. And they're saying that my time is every second is doing what? So at second 1, my velocity is equal to what? A times t, right? Right? V is equal to AT. So my acceleration is 5, my time is 1, and that is equal to 5 meters per second. Let's see time 2. So my next second, 2 seconds later, velocity is equal to acceleration times time. Okay? So 5 is my acceleration. My time in this situation is 2 seconds. 5 times 2 is 10 meters per second. The question is asking me, every second that passes, that object is gaining what type of velocity? The difference between this number and this number is how many? 5 meters per second. I came up with the 2. Because I said that second one, because we're doing a comparison. The question is asking you every second that passes. So at first second, this is what we have. At second, this is what we have. Because we're doing a comparison. So now I can answer the question. Now that I saw this comparison, I can say, okay, well, every second that passes, this object is gaining the difference between the two, which is 5 meters per second. Raise your hand if you still have any questions regarding this part. We're good? All good? All right, awesome. I'm gonna start working.